Hello guys, I am Mohammed B. Kapal. In this video, I would solve static of rigid bodies problems. Without further ado, let's start this. In this video, the topic that will be discussed is about friction force. The uniform 12 kilogram ladder in 6 meter long rests against the smooth wall at point P, and the end rests on the rock's horizontal plane, for which the coefficient of static friction is mu static is equals to 0.5. Determine the angle of inclination of the ladder and the normal force at 0 and P if the ladder is on the verge of slipping. So here is the figure, which is the 6 meter long ladder, and the next thing we need to do is to draw the free body diagram. At point P, there is a normal force acting on it, which is N sub O, and a frictional force going to the right. In a point P, there is a normal force acting on it, which is going to the negative x-axis, and a weight, which is W equals WmG. Then, the first thing we need to do is to solve for the weight. Weight is equals to mg is equals to 12 kilogram times 9.8 is equals to 117.6 Newton. Then we will going to solve for the normal force on P. To solve this, we need to use the equilibrium equation. The summation of f of x is equals to 0 is equals to negative NP going to the left plus frictional force going to the right is equals to 0. Then we will transfer the NP to the left, to the right, so that frictional force is equals to the normal force of P. We know that the frictional force is equals to mu static times N. Then solve for the N sub O. Summation of f of y is equals to 0. And sub O going to the upwards, which will become positive, and the wheel going downwards is negative. 0. Then transfer the weight to the other side. W. We know that W is equals to 117.6 Newton. After we can get the N sub O, we can now solve the frictional force. Solve for FF. FF is equals to mu static times N, which is equals to 0.5 times 117.6. The frictional force is equals to 58.8 Newton. When we solve it on the calculator. Then, the frictional force is equals to normal force, which is equals to 58.8 Newton. To solve for the angle of inclination, we will need to use the summation of moments. Summation of moments at O is equals to 0, because it was easier to find the moments at point O. So, N of P times the distance, which is 6 sine theta, minus, because the W is going downwards, it will go clockwise, is negative. Then W times 3 cosine theta is equal to 0. And we know that if we multiply this N sub O and F sub frictional force into 0, it will become 0. So we will not do that. Then NP is 58.8 times 6 times sine theta. Minus 117.6 times 3 cosine theta is equals to 0. Then we will multiply this by this 2.8 sine theta minus 117.6 times 3, also then 52.8 cosine theta is equals to 0. Then we will put this on the right hand of the equation. Then 52.8 sine theta is equals to 352.8 cosine theta. To solve the theta, we will going to multiply both sides by 1 over 352.8 cosine theta so that we can cancel this. We cancel and also this. So the one will be remaining is sine theta over cosine theta is equals to 1 because only one will be left, right? So in our trigonometric identity, sine over cosine is equals to tan theta. To get the value of the theta, theta is equals to the inverse tangent. Inverse tangent of 1, which is equals to 45 degrees. Summary. Theta is equals to 45 degrees and sub O is equals to 117.6 Newton and sub P is equals to 58.8 Newton. So, we're going to write 45 degrees. Thank you for listening. The next topic is all about center of gravity and centroid. The problem is determine the area and locate the centroid x bar and y bar of the shaded area. This is the shaded area. So unlike other problems, we are going to divide it by parts. So what I'm going to do is to add it to as a whole square. So after getting the area of this, the centroid, we are going to minus to the area of this. So, here it is. Let's solve for the area 1, which is the square. Area 1 is equals to 24 squared. S squared is equals to 576 centimeters squared. After getting that, we are going to solve the area of the triangle, which is equals to 1/2 base times height. Base is equals to 12 times height times 1/2 is equals to 72 centimeter squared. Area total is equals to 576 minus 72, which is equals to 504 centimeters squared. Okay. Then we will get the x bar 1 is equals to 12. Here it is, x bar 1. Y bar 1 is equals to 12. X bar 2 is equals to 1/3. Because we are from here, so 12 plus 12 minus 1/3 of the base. One-third of the base. 1/3 of the base is equals to 4. Then y bar 2 is equals to 12 plus 2 over 3 of the base, which is equals to 20. Then, to get the x bar, we will need to multiply the area to the x bar sub 1 and area 2 to the x bar sub 2 divided by area total. So, area 1, 576 times x bar 1 minus, because this is not part of it, we will going to minus that 72 area of this times 4 x bar 2 divided by 504. X bar is equals to 13.14 centimeters. Then y bar sub 2 is also, we can get this by multiplying the area times the y bar. So, area 1, 576 times y bar 1, which is 12, minus area 72, is area of this, times y bar 2, which is equals to 20, divided by the area total, 10.86. So, this is the x bar, and this is the y bar. And this is the total area. The third problem is about the parallel axis theorem. The question is, determine the area of the composite shape and find the IXX moment of inertia of a body along the horizontal of the centroidal axis. So this is the centroidal axis. Then the solution for this is by using the parallel axis theorem. Which is I double x is equals to 1 over 12 base times height. This is the solution for the type of figures like this, plus the area d squared. Okay, it varies when you are getting the inertia. So IXX is equals to 1 over 12 area 1 base is equals to 18. Then multiply by height 6 cube plus area of this is 108. Area 1 is equals to 108. Area 2 is equals to 96. Area 3 is equals to 108 centimeter squared. So 108 centimeter squared times the distance. So divide to 3 plus divide to 7 and 8. 8 plus 3 is equals to 11. 11 squared plus then area 2 1 over 12 times base is base 6 times height of 16 and cube plus 96 times, of course, 0 because it is in the origin. Then this area 3 1 over 12 times 18, which is the base, times height cube plus the area, which is also 108, times the distance. So 6 divided by 2, 3. Then divided by 2, 8. 8 plus 3, 11. And squared. So this will be cancelled. And the one will be left is, because this is similar, we will just going to 1 over 12 times 18 times 6 cube plus 108 times 11 squared plus, okay, we just multiply it by 2 because this is similar. Then plus 1 over 12, this times 6 times. So I of x at x is equal to I of sub x is 28,600 832 centimeter to the fourth. This is the answer. The next topic is about composite area. The problem is determine the total area and location of XY of the centroid C of the shaded area. This is the shaded area. And the thing we need to do is to make it a whole square, which has a side of 2.5 plus 2.5 is equal to 5, and as well as 5 cm. First thing we need to do is to find the area. Area of this whole is equals to S squared is equals to 5 times 5 is equals to 25 centimeters squared. Right? And then the area 2 is a triangle. 1/2 base times height is equals to 1/2 times base 2.5 times height 2.5 is equals to 3.125 centimeters squared. Then the area 3. Quarter of a circle. The area of quarter of a circle is just 1/4 pi r squared. So 1/4 pi times 2.5 squared is equals to 4.91 centimeters squared, right? And then the next thing we need to do is to add all the areas to get the area total. Sub 1. Then we will going to subtract this area minus a sub 2 and minus a sub 3. Area total is equals to 25 minus 3.125 minus 4.21, which is equals to 16.965 centimeters squared. So x bar sub 1 is, so this is the reference. So x bar sub 1 is 2.5. Here 2.5. This. And then y bar sub 2 is 2.5 also because of this. X bar sub 2. So x bar sub 2 is equals to 2.5 plus 2/3 because we are getting this 2/3. We started the vertices. 2/3 of the base is equals to 4.1667 centimeter. Then y bar sub 2 is equals to, from this we will add 2.5 plus 2/3 of the base. And we have y bar sub 2 is equals to 4.1667 centimeter. Then y bar sub 3, x bar sub 3 rather, is equals to, the formula is 4r over 3 pi. So 4r times 3 pi, 4 radius of 2.5. This is the radius, right? Over 3 pi. So when we calculate that, we will have a 0.6 centimeter. Then y bar sub 3 is also the same formula. It's equals to 4 times 0.25, 2.5 rather, 2.5 over 3 pi is equals to 1.060. We're going to check it if it's true. 4 times, okay. 2.5 over 3. So okay, this is confirmed, this is right. And then to get the x bar, similar with the previous topic that we discussed, x bar is equals to the area. times the x bar. So, area of the hole times 2.5 x bar minus, because this is not part of it. We're going to discard that. Minus area of the triangle 3.125 times x bar 0.166 minus the area 3 4.91 multiplied by x bar 0.06 over the total area. Now, when we calculate that, twenty-five, 30. So we will get 2.62 centimeter. Then y bar 2. Then similar with that, the area multiplied by y bar sub 2. Y bar sub 1 rather 2.5 minus the area of the triangle 3.125 multiplied by y bar sub 2 minus the area of the quarter of circle times the x y bar sub 3 divided by the area total. Right? So the y bar is equals to, similar with this, so we solved it a while ago. So it is also similar, 2.62 centimeter. So this is the x bar and y bar. So to locate that, we need to plot it. So 2.62, so 2.5, so approximately this is the x. This x and the y and the y bar is equals to 2.62. So this is 2.5, so probably in this they will meet at this point. So this is the center. The next problem is about product of inertia. The question is, find the product of inertia about x and y axis. So this is the figure, 14 inches, then 5 inches, then this 8 inches, then this is 18 inches, this is also 14 inches. So to solve this, we are going to solution. Find the area first. Area 1 is equals to 14 inches plus 70, which is good. Area 2 is equals to 4 times 8, 32. Area 3 is equals to, they're the same, so 70. So we all know that if shape is symmetrical, so the product of inertia at their respective x-axis is equals to 0. X and y-axis is equals to 0. So this is just similar. So they are all equal to 0. Y prime sub 2 is equal to 0. Then, after getting that, we know that this is all 0. Then we will use the parallel axis which equals to ix of y equals to ix prime y prime plus area times x y prime. So start ixy sub 1 is equals to ix prime y prime sub 1. So this will cancel 0 plus area of area 1 70 times the distance from this. So this is the x and y axis. This is y and this is x. So the distance of centroid to the origin. So 14 divided by 2, 7. So this is 4. So minus 2 equals to negative 5 because it is in the negative x-axis. Times the y-axis this. So 5 divided by 2, 2.5 plus 4, half of 8. So 6.5. Positive because it is on the positive y-axis. And then we will solve it. So 70 times negative 5 times 6.5 negative 2275 inch to the fourth. And then so this will cancel because it was 0. Then area of this is 32. So because it is on the origin, therefore x sub x prime and y prime is equals to 0. So this is equals to 0. So x sub y and x and y is equal to 3 is equals to x prime y prime of 3. So this will cancel. Plus, what is the area of this? 70. Multiplied by the distance of the centroid to the original axis, this, which is positive 5 because it is on the positive x-axis. So times 5. And then the distance of this to this of y. So 4 plus 2.5. So 6.5, and it is on the negative y-axis. So when you solve it, 70 times 5 times negative 6.5, so 70 times 5 times 6.5 is equals to negative 2275. Then you just add this 3. Negative 2275 inch fourth minus 2275 inch fourth. Is equals to negative 4500 inch to the fourth. So this is the product of inertia along the x and y axis. The next and the last topic that I'm going to discuss is about mass moment of inertia. The question is, find the mass moment of inertia about y-axis. The plates have a mass per unit area of 12 kg per meter squared. So this is the figure, this is the plate, and this is a hole in it, which is a circle. So to get that mass moment of inertia of this plate, we will find it by mass of inertia of this is equal to 1 over 12 mass times area squared. And for the circle, we have mass of inertia of the circle is 1/4 mass times r squared. So let's start this by finding the mass of this, excluding that. So 12 kilogram times 4.2 squared is equals to 211.68 kilogram. This is the mass 2. And for the mass of this circle, we have pi r squared multiplied by 12. Mass 2 is equals to pi 1.1 squared times 12 is equals to 45.62 kilograms. And then, we will use the parallel axis theorem. I of y is equals to summation of the inertia of that circle and this full plate plus mass times distance squared. So 2, because this is 2, we will multiply it by 1 over 12. This is the mass times the mass, which is 211.68. This is the mass times the distance. What is the distance? What is the area rather? So area is equals to 4.2 squared. This area squared. So, and then plus the mass, which is 211.68 times the distance. What is this distance? This is the distance, because we are getting the y-axis 2.1 minus, we are going to minus this two circles. So 2 times 1 over 4, because this is the formula, times mass. Mass is 45.62 times the area. Times the radius rather, 1.1 squared plus 45 area, 45.62 times the distance of the centroid to the y-axis, which is equals to 2.1 squared. Then, if we will calculate that, so we will have a 1,059.38 kilogram per meter squared of, so this is the mass moment of inertia.